I would like to really warmly welcome everybody to this Ekahau webinar series. I know we have got a ton of brand new people joining us for the very first time to this Ekahau webinar. And today we're going to be taking you through some fundamentals about Wi-Fi. So everything that you need to know for some basics and some great tips for how to perform accurate site surveys, analyze data, and then have a great performing Wi-Fi network. So Stu, maybe you can do a little quick round of introductions for us.
Absolutely. Thanks, Matt. So today we got a really cool guest here. Some of you may know her as which is Alexis. She's a solutions engineer at Cisco. She's going to be joining us today to kind of talk about some cool things that we're doing. With an overall Wi-Fi perspective, but giving her perspective on things. And of course, we've got Mr. Matt over here he's over to my right, I guess, on my on screen, and of course myself and Justin. And now back over to you.
Thank you very much, Stu. Alexis, maybe you can just say hello and quickly introduce yourself as well. I'm sure a lot of people here are very excited to see you on our webinar today.
Yeah, absolutely. Thanks so much for joining, y'all. I see a lot of familiar names popping up in the chat. If we have not met before, my name's Alexis Berthoff. I'm a solutions engineer at Cisco, and over the past 2 years, I've built a few platforms on social media. I've got about 150,000 followers now between LinkedIn, TikTok, and Instagram. And I post content about all things information technology, network engineering, and most recently, Wi-Fi. So very excited to be here today.
Yeah, thank you so much for joining us and being very modest. Your platform and the videos and the content you create have been amazing. We have really enjoyed watching them, and we're so happy to have you with us today on the Ekahau webinar. So a quick run through of the agenda. We're going to be covering lots of fundamental things you need to know about Wi-Fi, just some basics and some principles. After that, we're going to take you through some best practices for site surveys and tips, different types of survey modes you might want to leverage and use and try out yourself. Alexis has actually gone and done quite a few Wi-Fi surveys now and actually picked up her own tips, and she's going to be sharing them with you. And then what we're going to do is some live demos of showing you, once you've collected super accurate site survey data, what you can then do with that data to have a great Wi-Fi network. But maybe we can go back a little bit in time, Alexis, and actually just talk about how we met.
Yeah, absolutely. So about a year ago, exactly, this guy named Matt Starling dropped in my DMs and said, "Hey, how much do you actually know about Wi-Fi? Do you like free stuff?" And I said, yes, I like free stuff. So he hooked me up with an Ekahau Sidekick 2. And prior to that, I'd actually never done a site survey before. So I spent the past couple months kicking the tires on that. I took it around to some of my customers, got some actual survey experience under my belt. And we met for the first time in person at Cisco Live this past June. So you'll see me and Lexi, if you guys know Track It Pacer. And we had a great time out there. So it's been awesome working with Matt and the team and really seeing how this partnership continues to develop.
Yeah, and you even managed to get me to do a funny dance at the Cisco Live booth. You don't see it in this video. You see, obviously you're pulling off the moves. I didn't quite have them like what you did. I didn't do it justice, but it was fun making the video with you anyway.
Yeah, Matt said, can we make a Ekahau TikTok at Cisco Live and Lexi? And I said, oh, yes, we can. Matt said, you're gonna make me do what? Okay, I guess.
Yeah. If you want to see that video, I guess you're gonna have to head to Alexis's TikTok and find it.
Put it on my story this morning. It's not gonna die, Matt. It's on video
Oh,
forever.
okay, great, great, brilliant. Well, yeah, no, thank you so much for those videos. It was great to see, like you said, with Lexi as well. I meet you at Cisco Live and the fantastic content. People have really been enjoying it. Before you went out and did some site surveys, though, you did mention that you wasn't too familiar with Wi-Fi or site surveys. Was there anything that you used to kind of like build your knowledge to maybe give you a bit more confidence before you went on site?
Yeah, absolutely. So I did take my CCNA, CCNP, but never really had a ton of hands-on experience. I graduated college right in the middle of the pandemic, so a lot of my experience in networking has been virtual. So getting the Sidekick 2 and being able to do some surveys in person was awesome. What I had told Matt was, hey, I've never used this thing. You can't just drop it in my lap and expect me to figure it out. Is there any way you could give me some training? And what's great about Ekahau is they have a bunch of courses ranging from beginner level to expert level to help you learn all the ins and outs of Wi-Fi. What I actually did was the quick start guide. It took me about 4 hours, and it was enough to get me from ground zero, like never having used this thing before, to on site with my customer, showing them how to use it.
Yeah, that was super cool. I've just so quickly been able to pick up and then go and actually use it straight away. So I'm glad to hear that it was useful for you, Alexis. So the next part of the webinar, we're going to just cover some foundations and some basic stuff that we need to understand when it comes to Wi-Fi and principles. So for the longest time, we've had access to two frequency bands, which is the 2.4 and the 5 gigahertz frequency band. But more recently, going back a couple years ago now, we actually got access to the 6 gigahertz frequency band, which was amazing because the current frequency bands, they were getting very congested and lots of contention from so many devices and limited amount of channels that we could access on those frequency bands. So what I just mentioned there is channels. So how Wi-Fi works is on the frequency band that you're currently using, let's say if it's 2.4 gigahertz, 5 or 6 gigahertz, we actually communicate by leveraging channels inside of the frequency bands. So the biggest difference really going from 2.4 gigahertz is we have a very small amount of usable spectrum that we can use. Actually, when it comes to the size of a channel on the frequency band, the standard channel width size is usually around 20 megahertz wide. On 2.4 gigahertz, sometimes you have slightly larger, but don't need to worry about that right now. 20 megahertz is the default standard. You can bond channels together to get wider channels and leverage faster data rates and throughput, but there's some considerations to take with that. So on 2.4 gigahertz, realistically, we have three non-overlapping channels that we can use depending on where you are in the world. So what I'm talking about when it comes to frequencies and channels and rules, it will change and vary slightly depending on where you are in the world with how much spectrum you have available to you, what rules there are for the channels, and potentially what devices can do on those channels as well. So 2.4 gigahertz, typically now we would say most of the devices that are going to be on this frequency band would probably be IoT devices or really old devices, maybe some medical devices that haven't been upgraded yet and not capable of doing 5 or 6 gigahertz. 5 gigahertz has up to roughly around 25 non-overlapping 20 megahertz wide channels that we can leverage, depending on where you are in the world. And there are some different rules depending on the channels that you're using on 5 gigahertz, particularly the what we refer to as you've got Uni 1, Uni 2, Uni 3 band channels. Uni 1 and Uni 3 are not susceptible to something that's called radar activity or DFS, whereas the Uni 2A and Uni 2 extended channels, if there is radar or DFS activity happening around you, these channels actually have to work a little bit differently to play nicely with radar in your environment. But 5 gigahertz for the longest time really has been the main form of connectivity for your corporate devices. So if you've got laptops in your office or scanners in your warehouse, you would have been trying to get them onto the 5 gigahertz frequency band over 2.4 gigahertz because we've got more channels to use, less contention and congestion there. And then the 6 gigahertz frequency band is what got introduced just a few years ago to be able to be used with Wi-Fi. And that's fantastic. But if you're in the US, you actually get up to an additional 1.2 gigahertz of spectrum, which would give you something like 59 non-overlapping 20 megahertz wide channels. Brilliant. If you're here in the EU, you don't get quite as much as 500 megahertz, but again, still fantastic because it does give us additional, if you think about cars driving down a highway or a motorway, you had just the two lanes before, one for 2.4, one for 5 gigahertz. Getting that additional one, it means we can start to move devices into the 6 gigahertz frequency band. And not only is that a great benefit because we don't have to support legacy devices. The more devices that move over to 6 gigahertz, it makes those 2.4 and 5 gigahertz lanes less congested. So those older devices are going to have a better experience from more devices moving into 6 gigahertz. So there's just some very quick high-level overview of the different frequency bands and channels. I want to give a few tips when it comes to planning your Wi-Fi networks when it comes to channels, because it's such a crucial part of your deployment is having a good channel plan and making use of the available spectrum to you. A lot of people might have said, myself included, 2.4 gigahertz, that's dead, just use it for IoT bands, whatever. But maybe I'll have to eat my hat a little bit because 2.4 gigahertz, it can still be really beneficial and useful, especially with things like Wi-Fi 6, 11AX that is supported across 2.45 and 6 gigahertz, and Wi-Fi 7 will be supporting across 2.45 and 6 gigahertz too. If we can still leverage more highways and the frequency band to spread out those devices and across the frequency bands on those channels, that's going to be better for congestion. So currently, I would say 2.4 gigahertz. Some tips: you always want to stick to 20 megahertz wide channels on 2.4 gigahertz. Disable lower data rates so you don't have to worry about really old devices slowing your network down. And stick to three channels, which would be a channel plan of 1, 6, and 11. Yes, over in Europe, you could potentially do a 4-channel plan of 1, 5, 9, and 13. However, if you do that and your neighbors are using the 1, 6, 11 channel plan, it's going to cause you a whole bunch of issues. So just stick to 1, 6, 11. 5 gigahertz though, up to 25 non-overlapping channels, which is fantastic. Just need to think about if you have lots of radar activity in your environment, perhaps you're close by to an airport or a weather station. Just need to think about those channels that you might need to play around with and avoid. When it comes to channel widths in 5 gigahertz, what we would always recommend is use the widest channel you can until you can't, because it's going to give you faster data rates and increased throughput for your devices. However, if you're using wide channels and you notice that you have lots of co-channel interference or congestion in your environment, then you want to go down to a more narrow channel width. 6 gigahertz, very slightly depending on where you are in the world. If you're in the US, you can probably leverage 80 megahertz wide channels, the PSC channels, you might be referring to them here, and not have much congestion in your environment. However, if you try and do 80 megahertz wide channels over here in Europe, you may run into some channel interference, so you might want to go down to a more narrow channel width plan. But still amazing that we've got these frequency bands to be able to use and these channels. So that was some high level around frequency bands and channels. Now I want to talk to you about something that's called the inverse square law and free space path loss. And why this is a valuable thing to understand and know is because this is the formula that's typically used in like a Wi-Fi design tool, like Ekahau, for example, to visualize and show you the heat maps from access points when you're doing a predictive model. So first of all, the inverse square law effectively basically says that from the point source of the energy, each time you double the distance from the original source, you're going to have 1/4 of that power. So you can see here we've got 1 square at the first distance, but when we double that distance, we actually go to 1/4 or 4 squares. And then when we double the distance again from 2 to 4, we have 1/16, so 16 squares now from that original. And then where it gets a little bit confusing in Wi-Fi, 1/4 of the power, if I was to say to you, I don't know, you have minus 40 dBm signal strength here, and if you was to double the distance, you're gonna have 1/4 of the power. I think me included, before I went through my ECSE design class, I would have said, oh, 1/4 of the power from minus 40 would be something like 10 or minus 50. Doesn't quite work like that with Wi-Fi. Actually, every time you go up or down by 3 dBs, you either have twice the power or half the original power. So to have 1/4 of the power would be down by 6 dBs. And why that's kind of important to understand is we look at the free space path loss and we take a look at, we've got an access point here transmitting out of its radio. And let's say the radio is configured currently at 0 dBm. And we've got 3 radios, one for 2.4, one for 5 gigahertz, and one for 6 gigahertz. What happens in the very first meter is slightly different for the frequency band. So on 2.4 gigahertz, in that very first 1 meter, we're actually going to lose 40 dBs of power in that first 1 meter, minus 47 on 5 and minus 49 on 6. But what happens when you go from 1 meter to 2 meters? If you notice on 2.4 gigahertz, we drop down by 6, and on from minus 40 to minus 46. And if we double that distance again from 2 meters to 4 meters, it goes down by 6 again. So we're having 1/4 of the power each time we're doubling our distance. So it's slightly different between 2.45 and 6 gigahertz because of the wavelength of the frequency band. But what I want to draw your attention to here is the 6 gigahertz. So at 1 meter, we're going to have minus 49 dB of power if the radio is configured at 0 dBm. 2 meters minus 55, 4 meters minus 61, and then at 8 meters minus 67. So what happens is if you was to place an access point in complete free space and you transmit out of that radio, the natural deterioration of the signal coming from that radio. Now, if I show you our software, Ekahau AI Pro that runs on your desktop, I have placed a simulated Cisco access point here, 9166. And what you can see on the floor plan is the signal coming from the access point. And we've got our visualization legend here, basically shows you anything in color up to minus 67 dBm in signal strength. And we're looking at that 6 gigahertz frequency band. And what I've actually done here is I've configured the radio of the 6 gigahertz radio to be transmitting at 0 dBm. So if I come back to the slide here, what is said at 8 meters, we should have minus 67 on 6 gigahertz. Now, if I was to grab my ruler tool or the scale tool, and I drag from the access point to the edge, you can see at 8 meters where it then goes gray, that's where we have our minus 67 signal strength. So that's what we're doing in Ekahau to simulate the heat maps, to show you the coverage coming from the access point, that free space path loss, and the inverse square law formula to show you the heat maps. Now you're thinking, oh, probably wouldn't be configuring my access point radio to 0 dBm, and it looks a little bit funny. And yes, normally we'd have our radios configured to 14 to 17 dBm, which I've got here on 5 gigahertz. And this would be the more realistic expected pattern coming, the heat map coming from the access point when you've got your transmit power configured more in line with what you actually would. So what happens then if we are in an environment where we've not just got free space? I know when we design and place our access points, we have got usually walls around us and different types of obstacles. But when there's a physical material in the way, it's going to attenuate some of the Wi-Fi. That's what we call blocking some of the signals. And different types of walls, they're going to cause different types of attenuation. And typically a dry wall would cause something around a 3 dB loss. So at 8 meters before and 6 gigahertz, we was expecting minus 67. But now because we've got a dry wall in the way, we're expecting it to be a 3 dB loss here. So that makes it minus 70. I'll just give you a quick example in here too. If I was to grab a wall and I've got a dry wall here, and if I just zoom in a little bit and I was to just simply draw a wall, you should see the heat map starts to change. It didn't change too drastically with a 3 dB dry wall, but if I was to change this dry wall from being, I don't know, like a 3 dB dry wall to perhaps something like a concrete wall, that's 12 dBs, you can see that has a big impact on the coverage coming from the access point. So depending on the types of materials you've got in your environment, that's going to play a big part to how far that signal can go or how much is going to get attenuated by the wall for your environment. So it's key to understand that. And if you ever need to measure a piece of material for their attenuation manually, it's always recommended that you keep a 5 meters or 16-foot distance, because if I just come back a couple slides, when you look at the first like 4 meters, if you move just slightly, there's going to be such a big variation in that signal strength. You would see quite the signal jumping around very often and fluctuating. So being at least 4 meters or 5 meters away, you'd have much more of a natural degradation here, not such a steep curve. So we recommend keeping quite a bit of distance, go on one side, grab your Psychic 2, capture the signal strength, go on the other side, look at what the signal strength is on the other side, and then that's where you can understand the difference in attenuation of the walls and how it's going to affect your environment.
So Matt, what you're saying is when you're walking on the wall, you shouldn't be right up next to it. You should be a couple feet away.
So to be clear, what I'm saying is actually you want to be about 4 to 5 meters away from the access point. It's actually good to be right up against the wall, but the access point or the device that you're using to measure the signal from, you want to make sure that you're at least 4 or 5 meters away from that.
Got it.
But
Okay.
yeah. So I should have explained that better maybe. So thank you,
No, I'm
Alexis.
learning things today too. Thank you.
Okay, so I don't know if I haven't been paying too much attention to the chat whilst I was just talking, but I do want to ask everybody a quick question. Who here on the webinar today has ever been in a situation before where someone has asked you, hey Alexis, hey Justin, hey Stu, can you come and do a Wi-Fi survey for me? Anyone ever been asked this question before? Yeah, absolutely,
Yeah.
of course, every week. Yes, yes, yes. Okay. Now, why I'm asking if you've ever been asked this question before is I don't know how you usually respond to that if you get asked to come and do a Wi-Fi survey, but my typical response is, of course, I can come and do a Wi-Fi survey. There is nothing more that I would love to do in my entire life than perform a Wi-Fi survey of Ekahau. But what type of survey would you like me to do? Because there's different types of Wi-Fi surveys. Am I coming to your site to perform a survey to do a new design for you? Are you planning on upgrading your existing access points to new access points? Am I validating an existing design that you have that you maybe just had recently installed and you want to check to make sure everything is as it should be? Are you having issues? Is people complaining about the performance of the Wi-Fi network? Did Mac design and put this in for you? That why you need me to come and survey and fix it? Okay. Am I doing an assessment? You know, there's different types of surveys that you could go on site and perform, and understanding that would maybe change the way you would approach to go and do a survey on site. If you're going to do a really complex environment, maybe it's a hospital, maybe it's a warehouse or a manufacturing plant, you might want to take, like I've got behind me, an AP on a stick where you've got a specific type of access point and antenna you're planning to deploy on site and measure the signals and approach in a slightly different way. So I know we've got a ton of new people here, first time to the Ekahau webinar series. So thank you so much for joining us. And we just wanted to give you a quick guide on our path to awesome Wi-Fi. And really everything starts with a survey. If you've not seen this device before, it's what we call our Sidekick 2. And why it's so key that everything starts with a survey is because when you understand your environment and your Wi-Fi network and your Wi-Fi networks, neighbors networks, and what's going on in your environment, you have a much clearer picture on how does my RF behave? Do I have really heavy attenuating walls? Do I have lots of interferers? Do I have a really susceptible network to radar activity? Do I have issues where I can and can't mount access points? Is there interference here? I mean, some non-Wi-Fi interference that we need to think about. And I would say very typically now, 9.9 times out of 10, I'm sure people will correct me if I'm wrong or in your specific scenario, everyone's already got a Wi-Fi network these days. It's very rare I find, or when I was doing professional services, that you would be asked to go and do a design for a office or a space that has got no Wi-Fi, existing Wi-Fi network there at all. Maybe, yeah, yes, there's some new construction offices going up in cities and they've got no existing Wi-Fi networks, but typically you're going to go to somewhere, even if you're been asked to go and do a brand new Wi-Fi design, so you're going to do a Wi-Fi design survey, they probably already have an existing Wi-Fi network. It might be old, it might be a legacy environment, just 2.4 and 5 gigahertz Wi-Fi 411N network, but they already have existing Wi-Fi there. And you can go there, you can survey it, understand how it is impacting the environment and how RF behaves there. Once you have that data, you have data that you can then optimize. There's so many different intricacies and things that you can configure with Wi-Fi and SSID configuration, transmit power, channels, minimum basic rates. If you're brand new to Wi-Fi, it might be a little bit overwhelming. And that's why we have a product called Ekahau Optimizer that will automatically analyze your specific network against your specific requirements and give you a detailed action plan, step-by-step recommendations on what you can do to improve the performance on network from simple radio configuration changes. And then how do you keep on top of having a great performing Wi-Fi network? To be honest, you need to check it pretty regularly because things change all the time in RF. People bring in new devices, people remove devices, your network will change its configuration, your network's neighbor's network will change their configuration that can impact your network. So by regularly checking it, you can account for these changes over time and make sure it stays high performing. The amount of times I would go and do a survey of an office or a warehouse, and then I would go back a month or two later and I'd be like, oh, is this really the same office? The layout looks so different. They've taken out some of the walls, they've moved people around, the racking layout has changed, there's different stock levels of inventory, and that can have a big impact on the network. And if we think about our new workflow from what we can provide you with our brand new Ekahau AI Pro Online, once you've collected site survey data, you've then analyzed it in Ekahau Optimizer, you've implemented those radio level configuration changes, and now perhaps maybe that has gotten you to a certain point, but really we need to redesign the network, or it's time for an upgrade from old Cisco Wi-Fi 4 access points to new Cisco 6 gigahertz capable access points. And you want to understand, can I just take down these access points and keep their same locations if I put up new ones, or do I need to add move, add some access points or move some things around, but purely just based off survey data without having to draw a single obstacle, Ekahau AI Pro Online understands your RF environment. Even if you've only got older access points that work on 2.4 and 5 gigahertz, we can plan and show you what a 6 gigahertz network might look like. If you need to add some additional access points, if you need to move some things around, you can totally do that with Ekahau AI Pro Online. And I'll give you a demo shortly of both of these products in action so you can see for yourself. But the heart and soul of everything does come down to the Psychic 2 because it's super accurate. It contains everything that you need to be able to understand your RF environment because it's got 9 custom wideband antennas, which makes it super accurate for measuring the signals coming from all of your access points. Also, all of our Psychic 2s, they're calibrated, so it doesn't matter if me and Alexis are doing a survey at the same time with Justin and Stu, all of our data is going to be the exact same. We have 4 Wi-Fi radios inside of the Psychic 2 that are tri-band capable, 2.45 and 6 gigahertz. We have an integrated spectrum analyzer, which is going to be detecting any of those non-Wi-Fi interferers. If you've got people cooking their food in the microwave at lunchtime, that's causing you some problems in 2.4 gigahertz. Or if someone's got a RF jammer or a wireless video camera operating in your environment as well. We give you inside of the Psychic 2 the largest battery that you can take on a commercial airline. And I promise you, your leg's battery will die before the battery dies in the Psychic 2. And just 1 hour charge gives you 4 hours of active use. Uh, Ekahau, we have multiple different survey methods of ways that you can collect survey data using our application. So first of all, a very traditional method that a lot of people, if you've ever performed a Wi-Fi survey, will be comfortable with and use in the past, what we call stop and go. What stop and go does is effectively once you've got your Sidekick 2 connected to your device, you can use your laptop, your iOS device, your Android device, you name it. What happens, you'll have the floor plan loaded into the software. You'll go to a specific location, you will click start on the map. And what happens is for a period of time, by default, it's 5 seconds. It's going to collect data about the RF information for exactly where you are. And once it's finished collecting that data after 5 seconds, you then move to the next location. You get to that position, you click start again, it counts down and it collects data about that location. Now, if you was to ask me, like, Matt, do you recommend stop and go? I would say it has its place, but it wouldn't be my default method of collecting survey data because in between those points where you first click start and then collected data and then you move to the next location, that in between part, you're not collecting any data, and that could be really useful for analysis later on. So I would definitely recommend a survey method that's continuously capturing RF data, because especially if you're walking around anyway, so then, oh, why have you got a stop and go survey mode then? Well, there is obviously use cases and examples where this might work best for you and what you're most comfortable with. And if you're maybe in a slightly dangerous or hazardous environment where you've got to be really aware of your surroundings and you just want to go to position and collect data, then stop and go can be great for that. So moving on to the next one, continuous, again, been around for a really long time, and you can use this on your laptop, on your mobile device. You can basically have a floor plan and you go to a position, you click when you start walking in a particular direction, maybe down the hallway. And then as you get to a door that you want to enter and you're going to change direction, you'd click again, you'd go through that door, walk around. And basically every time that you turn or you stop, or even when you change pace, is you want to then be tapping and constantly telling the application where you're moving. And it's going to then track your position on the map. And then you have all of these data points that you can then analyze later on. Very traditional methods, I would say, stop and go and continuous. If you've been doing Wi-Fi surveys for a really long time, like I have been doing this, that's what we would be very familiar with. Then a few years ago, Ekahau came out with a new type of survey method called autopilot. Autopilot still works by putting a survey path on top of your floor plan, but now we can leverage the iOS devices, so iPhone or iPads, AR kit. So the camera, the gyroscope, accelerometer, LiDAR scanner, if you have it, and basically what Autopilot does is you give a couple of reference points, so where you're currently standing, then you walk to another distance. And a tip here is to try give as big of a distance that you can. You tap on the map again. And what will happen then is Ekahau will automatically track your location. It looks a bit like outdoor GPS, but inside. and you would just automatically have your survey path tracked for you as you move around the environment. So you can be very kind of like hands-free and aware of what's going on around you. And if at any point the calibration starts to get slightly off, you can just tap on the map and it will correct its location. And it's a great way of collecting survey data. So right on.
I will say with the autopilot surveys, tapping more frequently is better than tapping less frequently. I definitely ran into a couple scenarios where we got to the end of the building and it put us off of the map and we couldn't figure out why because we were like, oh, this is autopilot, it should do it automatically.
Yeah.
But just because it's on autopilot does not mean that you should not tap every now and then.
Yeah, it's a great tip from Alexis there. Like even though it's tracking you automatically, it will get better and smarter as well. Like you can calibrate it and make sure you're keeping you on the correct path. Which brings us on to our latest survey method that we have announced, which is called Just Go. And Just Go is super cool. I don't want to go into it too much now, so I've got a few slides I'm going to show you in action. But basically what Just Go can do is if you've not got a floor plan of your environment, or perhaps you've got an out-of-date floor plan, or you just want to really quickly collect survey data, you can simply connect your iPhone or iPad, if it's a pro version with the LiDAR scanner, to the Psychic 2, and without the need for a floor plan, out the need to set your location, you just walk and it will automatically not just track your location where you're walking, it will build the floor plan of your environment. And yes, it is super cool. I think it's the coolest advancement in Wi-Fi technology that I've seen. And I'm not biased by any means, of course. I'll give you a quick demo of it later on, but it's super cool. Great way of collecting data. GPS, if you're outdoors and you want to leverage the GPS chip of your device, you can then use this for an outdoor survey. It's going to automatically track your path. Tip, even if you're outdoors in a city or something like that, and you've got your maps for the outdoor environment, you can still use continuous or autopilot to like tap if you've got reference points. But if I know a lot of Ekahau users do surveys in places like mines and stuff like that, where you've got no reference points, it's super hard to like understand where you are and track your location. GPS can be a fabulous method of being able to calibrate where you're going. So it's a great tool to use. So depending on your situation and your environment, Ekahau provides you multiple different ways you can collect survey data. And I'm going to hand over to Alexis for a few moments to talk about your super accurate Wi-Fi survey tips. You are on mute, by the way.
It's one of those days, y'all. I just got back from PTO. Cut me a break, Matt. So I'm going to chat through some things that I learned, my tips from doing my first few surveys. So number one, we mentioned this a bunch of times, but walking on both sides of the walls is really important. Some of my customers' buildings, the customer that I first did my first survey with, they actually built skiffs for the federal government. And so not all of the walls in their office were the same, had the same attenuation value. Some of them were concrete, some of them were regular drywall, but that wasn't necessarily reflected on the older floor plans that they got from their design team. And we learned that during doing the site survey. So make sure you're going on both sides of the walls. Number two, only scanning the channels that you need. So there's a lot of different frequencies that can be going on in your office, but to get the most accurate survey for your users, you're going to get better, more accurate data by making sure you scan the channels you need. Number three, scaling your floor plan accurately. I'm going to flame Kevin here because I saw him in the chat. I think he said that you can just use a door or a door frame because it's 3 feet. But the most accurate way to make sure that your floor plan is up to scale when you start doing your surveys is to actually use a laser pointer over a greater distance. Remember I said when I was doing the continuous survey or the autopilot survey, my map kept throwing me off the edge of the map. One, that was because I wasn't tapping enough times, but two, I don't think our scale was completely right. So making sure that you have all of that information, just remember, garbage in, garbage out. So the more time you take to set this up properly, the better results you're going to get. Surveying accurately. So again, making sure that you are collecting data from the location you are in, not just blindly walking around the office and assuming that the Sidekick 2 is going to catch up with you on its GPS, but actually taking a look at your surroundings, making sure that it's displaying accurately where you are in the floor plan and keeping up with it as you go and taking your time is going to give you a better result at the end. And lastly, floor plans. So making sure your floor plans are up to date. One of the things that we ran into, our customer, they were a real estate investment trust. And so they were constantly making updates to their floor plans or their buildings, doing renovations for their customers that weren't always reflected accurately in their data, or in their logs, right? So what we ended up running into was their design team sent us floor plans. You know, we uploaded them into AI Pro, made sure everything was good to go the night before we got out there. Well, then we came on site the next morning and realized that half the office had been renovated and they never told anyone. So what we ended up doing was using the Just Go survey to survey the undocumented parts of the office and then combining that with the pieces that were still accurate on the floor plan, which, you know, some of those things you just can't prepare for. And lastly, using the Sidekick too, it really did make surveying super easy. I think we were able to complete it in like 30 minutes, and that was with all of the hiccups and figuring out how to turn it on for the first time and everything like that. But it really did make the experience so much more streamlined and easy, especially if you're new to wireless surveys.
Well, that makes us very happy to hear that even as a relatively new person to Wi-Fi, you was able to pick up the Psychic to connect it to your device and able to capture survey data. And we did promise that we'd show you a little bit of a glimpse of the Just Go survey mode. So this is actually me in the Helsinki office, and I've just got my Psychic connected to the survey application on my iPhone, and I'm simply just walking around the Helsinki office, and you can see the green on the walls here. So what's actually happening is it's detecting the environment, and you can see this bottom part down here is generating the floor plan as I walk around. So you can see the blue for the survey path, and then the walls that are being detected. And then when it finished, it looks something a little bit like this. So you see the access points, you can see the heat maps, and you can see the sketch of the walls. So I want to show you a comparison now between our London office and our Helsinki office. We've got the real floor plans of the offices there, and we've overlaid that with the Just Go survey sketch that it provided to us. So what you can actually see is, like, after doing the Just Go survey, how similar it actually was to the real floor plans that we had. So obviously not the entire floor plans, we didn't walk everywhere, we didn't have access to some of the parts were out of scope, but the areas that we went to, you can see it has built those walls there. And yes, it is a sketch version. It's not giving you a super high resolution version of the floor plan for now anyway. We see, who knows what's going to happen in the future. But when you're performing a Wi-Fi survey, the key thing that you care about is the data. So if you then compare on the left-hand side where we did an autopilot survey on top of the floor plan versus the Just Go survey, you see here we've got the details of where the access points are. We can see the heat maps, and the same on this side. We've got the access point locations. We can see the heat maps, and you might remember what we said earlier. Once we've got survey data, we have things that we can optimize and we can improve and act upon, leveraging things like Ekahau Optimizer. So you can see a Just Go survey inside of Ekahau Optimizer, the issues that we're currently having with a particular criteria that we're looking at, and then things that we can do to improve it. So if you're having, I don't know, maybe it's a fire drill, someone's called you up screaming, "Oh, Matt, the Wi-Fi in the office, it sucks. It stopped working today. What's going on?" If they've got a Psychic 2 on site with someone with a mobile device, you can tell them, "Hey, quickly just walk around the office, add me to the project," and then I can instantly see it in our cloud, Ekahau Cloud or Optimizer, and see what's going on. Perhaps there's been some new interference that's come in, or change in transmit power of the radios or in channels, or anything that could be causing issues. And straight away I can be like, "Oh yes, just do this, this, and this," and you're going to have some improvements.
So
So
Matt, there was a couple good questions in the chat that I think would be good to go over. One
okay.
of them was surveying in a non-traditional environment, which I think I can answer. Lexi and I did a survey of a shopping mall, right? No map, it was a Just Go survey, and it actually came out scarily accurate. I was shocked because there was so much glass in the mall. I didn't think that it would accurately pick up the walls, but it did a really decent job. And then number two, Matt, is how do you use a Just Go survey on an area outside with no walls? Like if it's a pavilion outside of an office?
Yeah, great question. And the way that I would probably approach that would be is it hopefully there would be some level of, external walls of the surrounding buildings. I would probably start by walking around those to get like the perimeter kind of exterior walls for the outdoor areas, and then I would walk in that kind of space. But I probably wouldn't use a Just Go survey mode for an outdoor space like that. What I would probably do if it was me is I would actually go to Apple Maps, Google Maps, some sort of map service, grab a screenshot, or you can directly import the Apple Maps from the survey application of that outdoor space, zoom in, and I would perform just a GPS or continuous or autopilot or stop and go survey on that outdoor area would probably be the best method for that. But great questions though.
Thank you.
Cool. So you might be wondering, what is the use cases for Just Go? I mean, if you've got zero floor, I know a lot of people in the chat are talking about Just Go survey modes, and some people reached out to me personally over time since we launched it about how they've been leveraging Just Go, but I can't tell you the amount of times that I've tried to work on a Wi-Fi project and I haven't been provided floor plans, or I've turned up to the site and they've provided me floor plans that are so wildly inaccurate that it just wasn't even worth the PDF that they sent over to me. But still, to date, the best one that I ever had was going to a warehouse. It was a 4 hour drive from where I live. The customer promised me that they was going to give me the floor plans, and I kept asking for them before I drove 4 hours. 4 hours might not be a lot for you people over in the US, but driving 4 hours in the UK, you can cover most of the UK in 4 hours. So it was a very long time for me. I drove there, I got on site, and I said, please, Mr. Customer, give me the floor plans. And they said, no problem, Matt, here you go. And they sent me an Excel sheet, which they had just drawn some lines on an Excel sheet for a warehouse. And I was like, how am I going to do an accurate site survey using an Excel sheet floor plan? So it's a great method to use if you've got nothing else available to you, or you just want to really quickly grab some survey data, just walk around simply. Or if you're like me and just want to geek out on new tech, I think it's the coolest thing ever, and I love using it. So I'm going to give you a quick couple of demos. First of all, of how you can optimize your existing Wi-Fi network based off survey data. And then if configuration changes isn't enough or you need to upgrade, how you can leverage AI Pro Online to redesign your Wi-Fi network. So there's a couple of things I want to show you quickly. So first of all, Ekahau Optimizer. I've got a survey file here from our Helsinki office. And what you'll notice is we get this nice network status page, and we've got all of these different categories and criterias around different metrics of our Wi-Fi network performance. So the way that we present this back to you is in a really nice traffic light system. So if it's green, we've got no issues, everything's good. If it's amber, it's some problems that we want to try and fix if we can. If it's red, like I said earlier, Mac probably designed and put this Wi-Fi network in and we need to fix it right away. So I can click on any one of these cards for an example, like primary coverage, and it's going to show me the different frequency bands on the left-hand side, the floor plan. It also gives you some best practices overview of the particular metric that you're currently looking at. Primary coverage is not too bad, I would say, from looking at this. But however, if we was to look at like secondary coverage, why you want good secondary coverage is to provide redundancy and roaming for redundancy from the access point, physical coverage level if you was to lose an AP, and roaming for your client devices. If access points can hear each other, they can inform client devices of their neighbors and can speed up roaming times. So you can currently see here we're at a 24% pass rate on 6 gigahertz for secondary coverage. However, though, if we was to implement just some radio level changes and I slide the slider, and I know all of you at home or at work right now are going, ooh, I know it's fancy. This looks cool. You can see that we have a much stronger secondary signal pass rate by making these radio level changes. If I want to see all of these changes, I can scroll down to the action plan. I can click on these access point changes, view all of the changes, and it details all of the access points, the radios. Configuration recommend changes for the channel width, for the channel, for the transmit power, even if they keep some radios on or off. So it's recommending disable some radios on 2.4 gigahertz. However, we're not just checking against like the probably what you would expect Ekahau to check against in terms of heat maps and coverage. We can actually take a look at how you've configured your network and is it in line with best practices. So here we're taking a look at your SSID configuration. Does it meet best practices? How about that your encryption? What about your minimum basic rates? Like what have you got configured currently? And again, you can come down to this configuration changes and see all of these proposed changes. You can download a PDF report from Optimizer and even a security report to see if you've got any interferers or rogue devices in your environment that you can then provide to your security member from your team. So if you implement all of these radio level changes and perhaps you're still having some issues on site, the next step would be for a redesign or adding some access points. Well, let me quickly show you our software online called Ekahau AI Pro that runs in your browser. And what we've got here is a surveyed Cisco 6 gigahertz capable deployment. And what I'm currently looking at here is the second floor and the signal strength. And you can see we've clearly got a coverage gap in this section here. I've not drawn any walls, any obstacles. It's just a survey file that's been uploaded to Ekahau AI Pro Online and it's analyzed the data. And what I can actually do now, if I click on this access point, I can see the coverage coming from this AP. Now, if I wanted to visualize in the past before, what would it look like if I was to move this access point from this room to this room? I would have to draw all of the walls. I would have to manually make sure that the attenuation levels are all set correctly. And then I could move the access point and it would predict that coverage. But now what I can actually do is grab this access point, move it around, and it will live show me how making a change, like moving this access point to a different location, how that's going to impact the network. So if I was to move it to this room, I can see, yeah, it's fixed the signal strength in this area, but then it's caused an issue over in this section as well. Bear in mind, I've not drawn any wall, any obstacle at all right now. So that's not clearly going to fix the Wi-Fi in this floor in this section here. I really need to add an additional access point. So I can actually add a simulated AP to the environment, such as if I click on the device tool, maybe I want to add in a Cisco access point with a redirectional antenna. And how I know it's a redirectional antenna, if I go on the additional settings and maybe I look at the 5 gigahertz radio, I can actually hover over this here. And if I take a look, it will actually show me the 3D visualization antenna pattern coming from this type of antenna. And what I could do is I could then place this access point here. You probably wouldn't place an access point with such a directional antenna in an office, but we're having fun here on the Ekahau webinar, so why not? I can put it here into this position and then see what that looks like. And I can see it's providing some really good coverage in this room, but maybe I want to put it in the hallway, or maybe I want to change the direction of the antenna to maybe shoot down the hallway here. And you can totally do that. Obviously, I could put in a 6 gigahertz capable access point as well. I can come here to Cisco or Cisco Meraki, pick my access point of choice. For example, change it to an integrated omnidirectional one. And that's what we would probably go with for the environment here. Put it in that room, and now you can see that it's fixed those coverage issues. But as a quick demo of Ekahau AI Pro Online, and I'm going to jump back to the slides because Alexis, I don't know if have you ever provisioned a dashboard before with the floor plans and AP locations? You're on mute still, by the way.
Maybe this won't happen again before the end of the webinar. It's embarrassing. I've provisioned my personal dashboard with about 2 APs, so it was not that difficult, but I've definitely been on the call with clients who have hundreds or even thousands of APs. And as y'all know, if you guys have provisioned APs in Meraki, you do have to drag them over to a map, review the inventory, look at the serial numbers, and it's not a super manual process, but it's also not super automated. And what's cool is through the integrations with Ekahau, using the API key, you can tie the two together to bring your Ekahau, like your live survey data, into the Meraki dashboard and automate that entire process. So not only is there no human error, it's also more accurate.
Yeah, so it saves a whole bunch of time. Stu, I think you've got a couple of demos just lined up to talk over here. First of all, with the Catalyst Center, I believe, right?
Yeah, actually, this is a really kind of a cool thing is what we're doing here from a Cisco Catalyst Center, with formerly DNAC, is we're taking this actually to the next level. So from when we're actually exporting our project or integration from Ekahau into Cisco Catalyst Center, we're actually doing it a little bit of a different way right now. Is what we're supporting is we're able to actually now integrate the actual project, and what it does is it will actually build out a set of tools. It'll build out the hierarchy, and it'll also build out the map. And we're doing this because we can actually be a little more flexible on what the data we put in. But what's really cool that you might have seen in the actual animation GIF there, because it went by super fast, is that you can now from a imported data, measured data, you're actually going to actually see, you can actually specify the antenna, because that's actually important. You can specify the model and the antenna. We see the AP and the MAC address, but we can also do some additional settings on there to add in there, which is actually super cool. Now, of course, when we get over to the design side as well, what we're doing is everybody loves APIs, right? Well, we're doing this here as well, where from an API perspective, when we're doing a design, we will automatically tell you that, hey, by the way, we know that you're designing for Cisco access points. We're going to make sure that we're going to bring up the DNA API widget, and that's going to automatically give you the login credentials so you can put your API key in and get off to the races. Now, the minimum requirement version here is 2374. This is one of the most latest versions of the Cisco Catalyst platform. So have a look at that. So really a lot of cool. And of course, our favorite friends, we've got from Meraki, we're not leaving them out either. That is actually a super cool integration as well. Same with the API key. So if you're on your dashboard and you've got access to the admin portion of your dashboard, grab an API key, designate it for Ekahau, and automatically put that in. You'll be able to choose your site, the map, and the floor plans, and you're off to the races. And that's my favorite feature right there, is you can actually rotate the building. Isn't that cool? You can rotate it and then place it exactly on the map where it needs to be. I find that's actually uber. Matt, I don't know about you, man. I think that little piece right there, being able to kind of motion the map where I need it to be, I don't know, what do you call it? I'm kind of like, I like to be exact, not as so perfect, right? But
Yeah,
like
a
super hot feature.
fun fact: the way that Ekahau was able to convince Mac and I to leave our previous employment to join Ekahau was because we had some outstanding projects where we needed to provision 4,000 access points manually in the dashboard. And we were like, you know what, if we can get out of doing that, then maybe that's the little cherry on the cake to get us out of where we was before to come to the Ekahau. So yeah, funny story. But uh, big news, we have our Wi-Fi day happening on September 19th. You definitely want to sign up early to this. We are going to be announcing the full agenda and presenters very soon, but we are going to be doing lots of very cool, fun stuff with Wi-Fi Day. It's going to be jam-packed, full of amazing content. So if you want to sign yourselves up early to make sure you've got your seat and that time slot saved on your calendar, because it's going to be a super amazing, fun day of Wi-Fi, then you want to go ahead, scan that QR code and get yourself signed up. Before Wi-Fi Day, though, we do have another webinar in between where we're actually going to be going to talk about designing for complex wireless environments. So we chose the word wireless particularly there because we might not just be talking about designing for Wi-Fi in a complex environment. It may be other wireless technologies as well. So in this webinar, we've covered a lot of the fundamentals and foundational things that we need to understand. And then we're going to go to a bit more of a complex, deeper dive into some of the more complex environments, things we need to think about to make sure you have a well-designed and working Wi-Fi network. A huge thank you to our superstar guest today and Alexis for taking time out of a really busy schedule to come and join us for our Ekahau webinar today, and Stu, Justin, the Ekahau marketing team, and everyone for putting this on. But most importantly, everybody joining us today on the Ekahau webinar. It was so amazing to have so many new faces along with all regular faces talking in the chat. I hope you enjoyed the fundamental webinar today, and we hope that we will see you on an upcoming webinar and especially Wi-Fi Day in September. So a huge thank you to everybody. And yeah, Alexis, thank you so much.
Thank you so much. Thanks for having me, Matt. Great to hang out with you all this morning.
Thanks for coming on. Thank you.
All right. Well,
Bye,
goodbye,
guys.
everybody. Enjoy the rest of your day.